Greeting everyone. So in previous class we have discussed the relation of resistance and temperature and so far, and then I gave you one question. So if you have done this question, then well and good. Otherwise today we will discuss this question and one more question today we will discuss. Thereafter we will go to circuit problems, and this will be the this will be the last segment of resistance and temperature. So let's read the question. What the question is saying? They are saying there is a little wire which is connected to ideal battery, and temperature of wire is increased by that much degree Celsius after a long time. Okay, then they are saying the length of wire is being divided into half, and what will be the increase in temperature? Specific resistance they have given, and the normal formula they have given. Here we should write delta. Okay, so maybe in previous question also I forgot to write the delta, but okay, this is the correct equation. Now let's see how we can do, because they haven't given plenty data. It is just a bare minimum, and we have to somehow scavenge something and find out how we can solve the question. Okay, so first let's discuss few things. This is your delta T, and that means your final resistance can be written as rho naught plus rho naught alpha delta T, right? So rho naught you can take common, so it will be 1 plus alpha delta T. Okay, and also one more thing we can do, resistance is rho L by A, so I can substitute rho, so this will be your what? Rho naught 1 plus alpha delta T times L by A. This is how we can write resistance as a function of temperature from this given data. Okay. So now what they have said one small clue they have given, that change in temperature has been done in a very long time. Okay. So if you connect any conductor to a battery, okay, so if it is just like a conductor, there is no coil, there is no parallel plates capacitor or something, then it will not have any parasitic capacitance or inductance, as also we can see they haven't said anything. So all the energy consumed by the conductor will be wasted in the form of heat. Means whatever power it will consume, it will waste in the form of heat. Right? So, and let's say the length is L and this is R. So we are assuming it to be cylindrical. Okay. Also it is wire, that means it has to be cylinder. Okay. So now, if you know a little bit of thermodynamics, you know that if you increase the surface area, heat will lose much quickly. Okay. Or you can also think it like some, if you are drinking a tea or something, then if you put in some bigger surface area, it will get cooler much easily. Similarly, here we can say the power dissipation can be directly proportional to the surface area, right? Surface area. Similarly, we can say the power dissipation is also directly proportional to change in temperature. If we combine these two, we'll get some constant. Let's say the constant is K. So surface area will be a 2 pi RL times delta T. Also we know power is V square by R. From there we can divide into two cases, where the length of wire is half and where the length of wire is L. We can divide into two cases. and because they haven't specified, we can assume in both cases they are connected to a same battery of EMF. Got it? If it is ideal, that means it has no internal resistance. Okay. And this will be your L and this will be your R. Here this will be your what? L by 2 and this will be your R. Also what we are assuming, that power dissipation we are taking in same amount of time. That also we are thinking. So now what we can do in case 1, let's say change in temperature is delta T1. So we can write P equals to P1 equals to V square or E square by R1. Okay. Similarly, we can write power as K 2 pi RL delta T1, right? And E square by R. R we can write what? Rho naught 1 plus alpha delta T1, and here you will have L and here you will have A. Right? This is what we can write. I can shift things here and there. So I can write delta T1 times 1 plus alpha delta T1 equals to E square A by rho naught L times K 2 pi R L. Got it? This is what we can write here. Similarly, here we can write power equals to E by R2, and similarly power we can write K 2 pi R L by 2, right, equals to delta into delta T2. This will be equals to what? E square A divided by rho naught 1 plus alpha delta T2 into L. Here also we will have L by 2, so this 2 will be here. Got it? Now again I can rearrange stuff. So if I rearrange, if you want you can cancel also. Here we can write a delta T2 times 1 plus delta T2 must be equals to E square A times 2 by rho naught L times pi R L K. Right? Nothing is missing. So this will be our equation 1. This will be our equation 2. Okay. So if I, let's say, divide equation 1 over equation 2. So if I divide equation 1 over equation 2, what I will have here? Delta T1 1 plus alpha delta T1 over delta T2 1 plus alpha delta T2 equals to what? Equals to, you will have two terms, right? Here in numerator you will have E square A by rho naught L times K 2 pi R L. In denominator you will have E square A times 2 by rho naught L pi R K, right? And here if you see, E square will get cancelled out, rho naught L will get cancelled out, pi r will get cancelled out, k and k will get cancelled out. So overall you will get what, 1 by 4 here, right? And if you do the cross multiplication, so you will get what, 4 times delta T1 plus 4 times delta T1 1 plus alpha delta T1, right? This will be equals to what, delta T2, let's open it, delta T2 plus alpha delta T2 square. This is what we get. Okay. Now, what is the value of delta T1? 100 degrees Celsius, alpha is 0.005. Now, if I substitute for this is your what, 100, this is 1 plus 0.005 times 100, here we will have delta T2 plus alpha delta T2 square, right? Now if you multiply this, we'll get 0.5 times 1 plus 1 is 1.5, so that will be 1.5 times 100, that is 150. 150 times 4 is 600, so 600 equals to delta T2 plus alpha, we can write alpha again, 0.005 times delta T2 square. Now it is just quadratic equation, you can bring it here, so 0.005 times delta T2 square plus delta T2 minus 600, 0. Now you can solve the quadratic equation, you will get what, delta T2 will be minus 1 plus minus we will not have, because temperature will increase, b square minus 4 is c, so b square is still 1 minus 4, a is your what, 0.005 times c minus 600 divided by your 0.005. Now you can, it is just numbers, now you can solve and you will get delta T2. So this is how you should have solved this question if you haven't, and if you have solved then it is well and good. So this was the question we have discussed, I gave you in previous class. Okay, if you want you can take a screenshot, you can evaluate what is the answer. Okay. Okay. Now see this question, and previous question if you remember it was from Pathfinder, and I think it is from JEE Advanced 2020 I guess. Right, it is fairly easy question. I know I haven't taught you Whitson bridge, but if you are in this segment, I am believing that you know a little bit about Whitson bridge. Even if you don't know, then it is still going to be easy question. I'll let you try for a minute. Okay. So in first case, it says it is a balanced Whitson bridge, means there won't be any current between this, but as they said that R3 has some alpha, means it will be, the resistance will be function of temperature, right? And the temperature has been increased by 100 degrees Celsius. That means after the R3 will change, then the ratio means after temperature increased by 100 degrees Celsius, our new R3 will not be equals to original one. That means here R1 by R3 will not be equals to R2 by R4. That means there will be current from the middle branch. That is the main thing. And let's calculate new R3. New R3 will be just what? original R3, 1 plus alpha delta T, that's the new resistance. Original is just 300, alpha is 0.004, 0.0004, and delta T is 100. So this means it will be one so this will be your 1.004, right? Now if you just multiply 300 by this, what will you get? 300. So 12, 1 we will get 1 and 0 and 3. So after, and if I multiply 100, it will be that many ohms, right? Correct? Let me check again. 1.004 times 312, and this one. Okay. So this many ohms you got new resistance. Now what you can do here, you can break the circuit into simpler part and we can solve it. Okay, so what was this resistance? 60. This will be 31.2. This one will be your, what they ask, half potential difference. So this is your S, this is your T, and this is your 100, this is your 500. Now you can simply do this question. I'll give you the hint. Here you will have I, here you will get I1, here you will have I minus I1, or you can take I2 also, because it is this same loop. You can apply KVL in this loop. So we starting from this. So 50 and direction of current is same. So again, if you don't know KCL, don't worry, in upcoming session we will discuss how we can solve this question. I1, that will be equals to 0. That's how you get I1, and then you can get I2. I2 will be just, we can make another loop. So this will be 50. 100 times I2 minus 500 times I2, that will be equals to 0. So this will give you I1, this will give you I2. Once you have I1, I2, then your part is done. Now you just need to calculate potential. Means you have to calculate potential difference between S and T. So you can start from S. So V at S, then you are going in this path. So if you are going in this path, so V at S, and direction of current in path is opposite. So plus 60 times I1, and here it is same. So minus 100 times I2, and equals to V at T. You can bring it here, and then you will get what? Vs minus Vt. This will be equals to what? 100 I2 minus 60 I1. Okay, so I1, I2 you will get from here, and you can substitute I1, I2 in the last equation, you will get your answer. So in next class, we'll start circuit problems. So these were your questions, and you can do it do it yourself by, you can see the video and try to understand. You should solve this question by yourself.